You're live.
I did. You're in.
Is there anybody here?
Hello.
All right, so, and most of you guys, everybody here knows me, so I'm not gonna make too much of an introduction here, but I thought we'd just do something a little different tonight, because normally we're going over measure quick or vacuum or something like that. And by the way, you can't evacuate in the cold. I got a nice video coming up on that. It shows that it is dang near impossible to remove moisture.
I've tried that.
Yep. Yeah, we did one, I pulled the system down to 135 microns at, what, do you think it's 30 degrees out? 20 to 30?
Yeah.
And 20 to 30 degrees. Pulled it down to 135 microns. Took it, did the decay test, went inside, let it warm up, it was over 2,000 microns when it warmed up, because the vapor pressure built back up. The vacuum pump could pull faster than we could sublimate, or the vacuum pump could overcome the sublimation. So the ice, when it's changing, gets colder, and it was pretty cool. So I got a video coming up on that, but it's pretty interesting, because I got into a discussion with people and they're saying, I said, you just can't evacuate in the winter, and these guys are like, oh, you're full of it, you can do it, I've been doing it for years, and I'm like,
Yeah, you did one
yeah.
doing it.
yeah, you can do it, but you're never gonna dry it out.
You better
It's gonna
oversize
get
your
something.
dryer.
Yeah, so, but anyway, so I thought I'd shift gears tonight, cause you know, we're in the software world, my company's been in the software world for a long time, and with the proliferation of AI, there's a lot of stuff going out there. People are starting to really look at, how can I use artificial intelligence to help me diagnose equipment problems, diagnose failures, increase productivity at work. So I thought I'd go over a little bit of that tonight. Just a quick question, how many or any of you, have you tried AI or used it for anything at all? Vincent has, all right, Mike, all right. So we got a couple people that have used it, and hopefully this will work, we'll see here. So there's first of all, what we were promised versus reality, right? So there was a silent robot that would dispatch your calls, balance your books, make you drink, do everything under the sun is what people are selling AI to do. And there's a fear we're gonna replace technicians, that everything's gonna become automated, that productivity, they're gonna expect 10x productivity and $50 million valuations on companies that have AI done. But the actual, what we're looking at is, AI is really just like an advanced autocomplete. It's just trying to figure out what the next thing is. And it cheats on its homework. It's about equivalent to a first-year apprentice and needs a lot of supervision. So there's a lot going on when you start using this tool that you have to understand before you put it in. So how fast is it moving? Well, if you look at this on a score of 0 to 10, 10 meaning that it exceeds human capability, we are flying up the scale right now. So in 2015, things like translation, they were at a 4, they could translate different language. You look down at like HVAC diagnostics down here, we're at a 0 in 2015. Today, we're probably at about a 5 on the HVAC diagnostic side, but you can see a lot of these things are getting to the 8, 9 area, and by mid-2026, we'll be in the 10s. So AI capability on a lot of these things will start to exceed a human's ability to actually do this stuff, right? So the growth is exponential. But this is coming at a huge cost. 165% increase in data power, in data center power demand, 17 billion gallons of water that it's gonna take to run this in 2023, trillions of parameters. And the irony is, it's a massive building full of servers, and for us, it's in the HVAC industry, this is an area we're gonna have to start really looking at, because what are we gonna do with this waste heat energy? In Finland, they're heating entire cities with it right now, because they have use for that heat almost year round. Here we don't, right? So why anybody have a guess why in Ohio data centers would be such a big deal? We have, how many do we have, Valerie?
215-ish?
215 data centers.
In all of Ohio or
In
northern
all-
Ohio?
Ohio.
In all of Ohio.
Because you're not allowed to take Great Lakes water out of the watershed anymore.
No, yeah, to use other sources.
Use other sources, yeah, this goes to back to Valerie, you see she sent me this just from today. She was on the EPA public hearing today listening about wastewater discharge. But basically, huge amounts of heat energy, it's all consumed waste that must be removed. So all these computations, all these CPUs, they're all doing all these processes, they gotta get rid of that heat energy. Great Lakes are an attractive reason due to the power and abundant fresh water, and they constrain the municipal water supplies, right? So warm water discharge causes thermal pollution, so if you think about if they're discharging that water, it goes back into the rivers, back into lake areas.
Different things grow in different temperature.
Different
waters.
things grow in different temperatures, yeah. This is the same problem we had with nuclear back then. Nuclear had the same thing, right? AI demand grows, cooling water demand scales rapidly. And so, you know, Valerie, this is something like, this is gonna impact our kids, it's gonna impact, our neighborhoods, everything else is gonna, we're gonna see an impact of this because the industry's growing so fast and it's not gonna be regulated well. So one of the things, like I said, we're gonna have to figure out is what are we gonna do with the heat energy? I mean, there's a lot of things that could be done, but I don't know what we're gonna do with it year round.
Well, Perry had those,
Cooling
hyperbolic,
towers. But you
because
still
they
got
couldn't dump it
wastewater.
all in the lake area.
Right, couldn't take all the heat energy out.
Yeah.
So, what is this thing, we're talking about AI, I figured a lot of you have not used AI, or you have no idea, and you go, I don't even care about AI. But it's something that you're gonna wanna learn a little bit about, because I will tell you, I am 100% confident your job will not get taken over by AI. But I am also 100% confident that your job could get taken over by somebody that knows how to use it. Because we're getting in a position now where technology is advancing so rapidly that it's gonna be something we're gonna interface with whether we like it or not. Even your iPhone today has Apple Intelligence on it. So now you're not interfacing with basic Siri anymore. Everything you say goes out, gets processed on Apple servers and comes back to your phone almost in real time. Right? You can put your earbuds in and you can listen to somebody speaking in Spanish and it'll translate it in real time in English in your headset. So I mean, things that are happening are pretty amazing. But when you think about AI, first thing I understand is like a deterministic calculator. So 2 plus 2 is always 4, right? It's gonna be very consistent. Well, AI is a little bit different. It's called a probabilistic or a large language model. And what it's trying to do is it's trying to fill in the blank. All AI does is go, you know what? What did they think, what word is gonna come up next? If you've ever typed a text message and you've seen like Apple pop the words up, it's always guessing what word are you gonna put in next in there. So when you say, I'm about to go to and it's gonna say store, or I'm gonna go to and it's gonna say, oh, it's not my store, it's probably my house.
You gotta get the first 2 letters right. Then
Right,
use the rest
and
of
then
it.
it'll fill out the rest for you. So the condenser fan is, and it's saying, 45% chance you're gonna say broken, or you could say spinning, or you could say loud, but it's trying to fill in the blank for what the next thing is. And so it doesn't know physics, it knows which words appear, and it tends to like think about, well, what words are gonna be near superheat, or things like that, right? So it's a crazy little model, but it actually does very well for a lot of things, just not everything. So, why does hallucinations happen? Well, the AI doesn't know the answer. It's programmed, it's plausible sounding. And this is the problem with AI is when you start using it, it'll tell you things that sound so real and so plausible, and it has such authority that you actually stop and you pause for a minute and you say, is this right? And probably most of the time it's not, because it makes mistakes along the way. So I spend a lot of my time arguing with AI when I'm out doing things. I'm training the model.
Isn't that like
sometimes.
arguing with somebody on the radio?
Yeah, it sort of is. Yeah, it's sort of. So the problem with AI is it's the yes man. It wants to please you. Like you're talking about, if you're an advertising company, right? They want to feed you the right advertisements. AI wants your experience with AI to be good. So AI is, you think you're training it, but it's actually training you. It becomes an echo chamber, and it can be a good echo chamber or it can be a bad echo chamber. But it can start to do things like, if you're out there, and this is a dangerous validation example, TXV must be bad, superheat's only 5 degrees, right? Well, AI is gonna tell you, yeah, superheat can indicate a bad TXV. In reality, the TXV is doing its job. It's just, it's not a bad TXV. If we had a bad TXV, the bulb broke or whatever, we'd have high superheat. we probably have a low load issue or something else going on, the bulb could be loose or something, but the AI will agree with you because it wants to it wants you to continue to use it, right? It's the way they do it. It's got trained helpfulness metrics. It's an agreement, satisfied user. Disagreement, it's gonna get negative feedback. And it prioritizes satisfaction over truth. That's something a lot of people don't realize, is it becomes an echo chamber of your ideas. So AI is not somebody you wanna have a discussion with about God, right? Or about marriage, or about what you should do in your life. This is where people that get counseling and stuff, where we're hearing, people are starting to interface with AI and it becomes a danger to them. How to counter it? Never leave with your conclusion. Right here I'm saying TXV must be bad. I'm already giving it a conclusion, so AI wants to agree with me. You never want to lead with your conclusion. Ask what could cause these readings. Provide data, not your theory, right? AI can do a really good job, and I'll show you on this. I have some examples I'm going to pull up on my phone in a few minutes here. But it'll do a really good job if you provide it with measurements, if you provide it with makes, you provide it with model numbers, serial numbers, photos of labels, photos of the equipment you're looking at. It can actually look at a photo and it can determine wire colors. If the wiring schematic is the same wiring schematic that the equipment has. There's so many things you can do with it, but you need to understand its limitations. And so when you want to do this, there's two types of prompts. And this is the big reason people think AI is stupid. It's also the same reason that people that use AI, their service managers, think they're stupid. Because these are the guys who go up on the roof and say, hey boss, I'm looking at a train YCD060LOAB. What's the most common problem with it? Right now, there's technicians, and I know you, and I worked for Gardner Train for years. I'd have technicians call me and ask that exact question.
What's the
I'm
most
like,
common
dude,
problem?
have you even looked at it yet? Well, I'm just walking across the roof and I just want to get a head start. Click, hang up the phone.
Yeah.
It's too general of a question to give you any kind of answer on. And it's the same thing people do with AI. Why is the unit freezing up? Well, it's going to respond. You got to check your filter. You could have low refrigerant charge. Your evaporator coil could be set too dirty, or it could be too dirty. Thermostat could be set too low. Very general response. It's probably not even helpful. It's just a list of things that you might look at most elementary level. A good prompt is using a prep method, and I'll show you what that is in just a second, but we're gonna give AI a role. And so you're gonna tell it, you're a senior service technician. And the context is, I'm working on a 1995 Carrier gas furnace. The limit switch is tripping after 5 minutes. My total external static pressure is 0.8 inches of water column. Now list the top 3 causes of low airflow restrictions, and don't suggest placing parts until it's confirmed. So it's result specific, it's actionable, it's prioritized by probability. And this is what this whole idea is. It's the prompt or the prep method. So a persona or a role. You have to tell I that you're an expert at commissioning systems. You're an expert on steam systems. You're a service manager at a company. You have to give it a role and tell it what you want it to do. So act as a senior manager with 20 years of experience. It constrains that AI not to think like a junior technician.
People pleaser.
A people pleaser, right. You're giving it reference, so you're providing it with model numbers, readings, symptoms, photos, manuals. Anything you want to feed it, you can fill in there. And then you are asking for an explicit request. So what's the cause? What things should I look for? What other measurements should I make? And then you're giving it some prohibition. So you're saying, don't suggest part replacement, or don't tell me to add refrigerant ever before airflow is checked, right? So there's things you can do that in this prep method to do that. And it's a chain of thought, it's a few shot examples in the context window, right? So you can upload all this stuff into AI. Now, when we talk about AI, it's the same features, a lot of the same features, but different names and different types. So we have ChatGPT, Gemini, Claude, Grok, and Grok is Elon Musk. ChatGPT, I think, is Bill Gates. Gemini is Google. I'm not sure who Claude is right off the top of my head on there, but It all depends on what you wanna do with it. I primarily use ChatGPT. ChatGPT is sort of like a polished college student, right? Grok is like the really smart, sort of sarcastic college student, sort of like your dad. So your dad would be Grok type, highly intelligent but annoying. Gemini is more like the librarian. It sort of knows everything and has read everything in existence. And Claude is not one I have ever used. One of my partners use it all the time, but he said it's great for like bigger projects in there. And so you can play with all these different models here, but you'll probably find one that fits your fancy better than others. Claude, best for deep technical work, manuals, diagnostic reporting. ChatGPT, I use it a lot because it's very fast voice to text. So I can talk to it and put a statement into it. It'll works hands-free, and it's got that, like, I don't know, it's very, very fast and good responses on a mobile application. Grok, I've played around with. It's a little edgier, wittier. I think it's more of a social media tool than it is an AI tool for anything. I have not found anything I'd really like to use Grok for yet. So, but if you want to know what's going on in Trump's world or something, Grok will tell you that's probably what it's best for. So, which one for tasks? Well, Ben, one of our guys at the office, ran through and made this checklist for us here. And you can sort of get an idea if you talk about reading manuals, you know, Chat or GPT, Grok, all of them would do good reading manuals. Proposal writings, Crossroad, field support, documentation, combustion analysis review, probably be Claude, wiring diagrams. So each one of these has a little bit of a little bit better at some things than others, which it looks like I should be using Claude when I don't even know what it is. So not a model I've worked with. So this slide here, I wanted to just take over. This is again that user interface. So I'm gonna open up a GPT window and we're gonna put some data in it, and then we're gonna do this live and get some answers and just sort of see what you guys think, how it works. Now, in MeasureQuick specifically, what we found out, what we wanted to use AI for was all the stuff that nobody wants to do. And the whole idea was behind it was like, okay, AI is neat, but I don't really want it troubleshooting equipment for me. I like to do that. I want to do that. If I'm going to use AI, what do I want it to do for me? Well, I don't like putting all the makes and models and serial numbers of equipment into MeasureQuick. That's a pain, putting all those numbers in. So we used AI to read the nameplates and parse all the data into MeasureQuick, so we get all that make, model, serial number, input of the furnace, minimum gas pressure, maximum gas pressure, total external static pressure, you name it, anything that's on that label we can pull off that. Now, inadvertently, we ended up dramatically improving MeasureQuick. Can anybody guess why?
Made it easier to use.
We made it easier to use, that's for sure, but that ease of use did something else for us also. It had a huge impact on the, I'll tell you, it had a huge impact on diagnostics as a clue. Why would we have better diagnostics?
It's unit specific.
Accurate information.
Yeah, accurate information, right. If you're a service manager and you call somebody, some of the most important things you can tell me are what's the make, model, and serial number, what's the target subcooling on the data plate, you know, what's the rated steam pressure, whatever you want to ask, but that information about that unit helps us a lot to actually provide an accurate diagnostic. So what happened was we went from this very broad information to extremely granular information about units. Today, like we track in the background, and whenever anybody does a test in MeasureQuick, company by company, we pull about 230 pieces of data about every system that you touch. And that could be who worked on it, when they started, when they stopped, what the make, what the model number is, what probes were deployed, was a high pressure probe, low pressure probe, liquid line, suction line, return air, supply air, outdoor air, supply static, return static, did you use a combustion analyzer? All that data is pulled off. We know what readings came off of live probes and what readings actually came off of hand input in the MeasureQuick. We know if you waited for the unit to stabilize before you did an analysis. We know how it tested in, and we know how it tested out. Now, we don't use that data for anything. It's collected and it's used for your company, but what we can do is run a report then back on that data and determine, now using AI, how many systems that you actually touched and improved in operation, how much they improved in operation, how many systems you left with an overcharge or undercharge, how many systems had high static pressure, tons of information about how equipment operates, and then we can build a software around better diagnostics so we can help people solve those problems in the field. Or do things like, hey, did you realize that if you use static pressure probes, you would, I keep hearing something in the background.
Is that Myron?
Myron probably. As long as I know it's Myron, it's all right.
You able to mute his mic?
Hey Myron, mute your mic. So, the whole concept here was we ran an analysis on some of our biggest customers. Our largest customer this year, they probably did, in June, July, August, and September, they serviced 14,000 systems. Right, in 4 months, 14,000 systems. So just to give you an idea of the size of the company they are. They, at one point, they started using MeasureQuick. They had a change of leadership. They got bought by a PE firm. They had a change of leadership. They brought a new owner in, and they said, what can we change? Where can we cut corners? And they're like, yeah, we're using this MeasureQuick thing. We don't really like it. Let's get rid of that. They lost $900,000 in I don't know how many months. I want to say it's 3 or 6 months in callbacks on there because their guys were not following a process when it came to actually commissioning equipment. So they were getting massive amounts of callbacks, cost them a massive amount of money. We started looking at what things that they weren't doing, and their guys were doing things like not deploying static pressure probes, so they were losing ECM motors on there. They were not doing proper evacuations. There was, you know, think about when you have a company of that size and you have over 1,000 technicians, you get guys all the way at the bottom that are just starting out that were landscapers one day, and they got their EPA certification, now they're service technicians and they're just throwing them out to the wolves. You got the white shirt guys that are out there, they can't fix anything, just trying to sell whatever they can sell. You got a handful of technicians that can actually fix things. I mean, there's a wide variety in these types of shops out there. But the whole thing is that we're able to put a process in place. We're able to look at what techs were doing the best work, we can also look at through job dispatching, we can look at how many times were they dispatched out to the same house within the same so many months. So we saw some of these jobs that are out 5 times in one month out to that house. So it means over and over, callbacks on those jobs. Those are revenue losses for those companies. So we can start to look at where they're losing revenue. We can show that the technicians that are consistently deploying all 9 probes on every job every time are consistently getting better results out there. And we also know, we can look now at equipment level because we have AI profiling on here. We can look at equipment level, what equipment's actually operating the best, what brands of equipment are operating the best, what makes or models are operating the best.
Oh, that's handy.
It's just all kinds of different things.
We've all been asked that question. What's the best brand of unit to get?
The one that's installed
One I've
properly.
never heard on because I get called out to fix them.
Yeah. All right. So I'm going to see. I don't think I got another slide after this. So there's a couple of things that you don't want to ask AI to do, right? You don't want to life safety critical things like never ask if your piping's safe or are your brakes safe, or AI can't smell gas, it can't see cracks, it can't see defects, it can't feel vibrations. And this one here, frozen pipe hallucination, ChatGPT advised homeowners to check the refrigerant levels themselves, right? Dangerous and illegal, but people are asking right now, they have these large language models and they're saying, hey, what do I need to do next? And ChatGPT's like, well, check your refrigerant level, right? Wiring without verification, customer PII. So personally identifiable information. So you never want to put in names and addresses and things like that, especially if you're in the state of California, because you're training people off other people's data. So there are some things, if you're going to use this, that you just need to be aware of. All right. So the we're gonna go over a couple examples here, but here's what I want you to understand. You know, we're probably in the safest industry right now in the entire, ecosystem of jobs you could have in the HVAC industry, because what we're doing is physical. AI can't climb the ladders or raise lines, it can't sign off on tests, and customers want humans to do this type of work. They don't want an AI bot to tell them what's wrong with their thermostat, they want a human to come out and look at it and figure out what's going on. So we're in a really safe mode here. And stats right now show the HVAC industry has 0 displacement risk and 17% growth. So data centers are gonna be big for us. We're gonna have a lot of growth in our industry. The real threat, and again, it goes back to what I said earlier, is techs using AI are gonna probably replace techs that don't. And I was not a really big believer in this until I started using it. And after I started using it, the productivity, would you say probably 10x, Valerie? I know on the programming side, but
Oh, yeah, programming, yeah.
we've 10x'd on the programming side. And then just personally, I mean, I use it just for checking my emails or polishing an email up before I send it, or some basic tasks. It does really good at that. What AI does well is, and this is where everybody makes mistakes, is you do not wanna let AI think for you. You wanna think, do all the thinking, and then let AI polish the thinking. It'll just restructure it, reword it, maybe clarify it. Does a great job at that kind of stuff. But if you don't have the right questions, it's not a question, it's not an answer engine. I always frame it this way. It's a question engine. You have to ask it the right questions with the right prompts, or you're gonna get a bad output on there. All right, so for some of you guys that haven't played with this, I actually I took some screenshots on my phone, and we'll just do a couple of little things here. I just gotta pull up this Epson thing and have Tom switch me over on there once I get it up. I think I'm ready. See if it works.
Yeah. So that's where you're going.
I don't think you're up yet, Joe.
I'll try it again. Mirror screen, start mirroring, start broadcast. All right, now it should be working. I'm definitely working now.
Okay, there you
we go. All right, I don't know if we can shrink that down or if it's stuck the way it is, so we'll work with it like it is. All right, so what I'm gonna do here is I'm gonna pull up ChatGPT, and then we'll just go here and we will
Thanks for
start a
coming.
new chat. So you can do pretty much anything. It starts like this: ask anything you want to ask on it. So let's just go ahead and we'll go into photos here, and I'm gonna put in a. Let me see which way I put these in here. All right, so we'll just start with this, and we'll start with just a basic prompt here. Tell me what's wrong with the system. So we're giving it a lot of data here. Let me just show you what data we gave first. Let me just tap on this. So what I've given it here is, and I literally just walked out in our shop before I left here, and I started an air conditioner up in the shop. So this is just well, you can see it's 3:01, so it was just 3 o'clock when I did this today. So at a glance here, anybody see anything in here that's
What's the refrigerant?
R410A?
Is there suction? And it knows that?
If you don't know what any of the numbers are there, just let me know. As far as it's a grid view, so it's just all the readings. The up and down arrows are telling you, like,
Well, liquid line temperature sure is low.
yep, and that's because look at my return air dry bulb at 65 degrees. So my liquid line temperature is low, but I do have 2 degrees of approach,
Yep,
right?
which
So,
means you're condensing.
which means I'm condensing, yep. Change in enthalpy is low, but that doesn't surprise me. What's, just at a glance there, what's a good reason we'd have, a couple of reasons we have low change in enthalpy. Enthalpy is total heat removed, so that's your heat and humidity. So,
Maybe too much, not much, moisture removal.
that's right, yeah, it's dry, we're in a shop out there, it's dry, there's not much moisture removed, that's one thing.
Where's the condensing, or the outdoor air temp in this?
Outdoor air temperature is, right here, 65
Okay.
degrees, 64 point.
So you got low head to start with.
Okay, and what's that
Yeah.
gonna give us? You're on the right track, you're gonna go to the
Yeah.
same place I
Yeah.
was.
Suction pressure is gonna be low because you got low head. You're
Could
not-
be.
Yeah,
Right? We have an oversized evaporator in this thing, but differential pressure across the metering device is low.
yeah.
So typically we wanna have about 160 pounds across the metering device. Right here, we have about 115 pounds or so across the metering device, so that's another reason we're gonna have low capacity. So let's see what AI says so here's the straight engineering first, okay? Now, I've used this, we're literally on my brain here. So what's happening is, I've used AI so many times and I've corrected it and told it, hey, don't do this or don't do that, that even when I ask it a stupid question, it gives me a halfway decent answer. The first time you use AI, and because it goes back and it keeps a history of everything I've ever asked it. Unless I permanently delete that history, which you can do. And if you're gonna use AI, the other thing you wanna do is make sure that I intentionally went in and shut off training the AI model. So it always defaults as, hey, do you wanna tell everything you told AI to the world and help train our large language model so we can make it smarter? I'm like, oh, no, hell no. Yeah, I'll just keep it local on my phone and play with it and use it for what we wanna use it for. So it's saying, okay, here's the straight engineering, right? Airflow is too high for a 1.5 ton system, measures 675, so it's looking for about 400 CFM per ton. Now I can do things like pick up where our geolocation's at, so it can say, okay, you're in a mixed climate in Ohio, so 400 CFM per ton. If you were in Arizona, you would be at 450. If you were in Florida, you might be at 350. Your airside indicators of 19 degree splits borderline for properly loaded coil. Low latent capacity, there you go, Phil. Phil got the latent capacity right. The coil's not removing moisture aggressively. Supplier wet bulb is 39.1, that's cold, but it's not working hard. Classic signatures of excess airflow washing the coil. Refrigerant side, not the root cause, so it's giving you a superheat and a subcooling. Approach, refrigerant circuit stable and it's correctly charged, it's not a charge issue. Static pressure, confirms are at 0.4 static, so it can move the air easily. And secondary effects, reduced latent capacity, lower coil dwell time, comfort complaints. So it's saying, hey, if you don't slow that airflow down a little bit, you're probably not gonna dehumidify well. And icing risk is condition shift. So what it needs to fix, reduce the airflow down, recheck delta T, delta H, wet bulb. What not to do, don't add or remove refrigerant, don't chase the head pressure. See, Tom, it's knew you wanted to chase the head pressure.
Yep.
And the master rule is you're gonna create the callback. So, system mechanically healthy, charge is correct, airflow is wrong, here's what to do. Right, so next step, we can calculate the exact target airflow for this equipment, predict post-adjustment delta H, or we can frame this. So, it's amazing if you just stop and think just for a second, we just asked it a basic thing, but here's what I want you to realize that what we did. Well, I'll ask you what we did. There's something that we started off with that was pretty critically important. What was that?
Information in.
Yeah, we have a lot of information in, right? When we went up to the top here, we provided it this is all measurement information. So I'm not telling it, if I started off and said, yeah, my suction pressure looks low, my head pressure looks low, right? Because it's cold outside. The software has already determined what all the target pressure should be. That's what these check marks are. So everything with a check mark means it's in range. So return air dry bulb at 65, that's a low temperature. That's a low temperature for running air conditioning. The software figured that out already, right? Same thing with the return air wet bulb. Static pressure in the return air static is 0.27. That's a little bit high for return air static because we got a restricted filter. Our airflow is a little bit high. Outdoor air temperature is a little bit low to run that. All right, so let's let's try another one here. I'm just gonna try a new chat here. And we'll go back in and we'll do the photos here. And we'll give it a little bit more information this time. So,
It's too bad he couldn't have figured out that problem on the board that was up there for 5 years.
Yeah,
alright, so let's throw it a
100-pound delta.
little
Yeah.
bit of a loop here. We'll give it a couple problems here, but I'm gonna give it a little bit more information also. So I'm gonna give it the air handler. Alright, so what I did here is I've got, don't wanna give it that one. Alright, we'll give it these. Alright, so what I'm giving it now, we'll just take a peek at this photo here. So now we've definitely got a fault in here. And you can see there, we've got, the software saying we got really low pressure. We got higher than normal high pressure. Return air dry bulb's still the same, still 65 in the shop. Supplier dry bulb's 37. Delta T's up to 27.7 degrees. 19.4 degrees of approach, no superheat, and low subcooling.
No, super.
No, well, look at the, and how do we know we got no superheat? Because we have a 30-degree evaporator and a 29-degree suction line temperature. So can your suction line actually be colder than your saturation temp? Well, it is, because we have uncertainty in our measurements, right? So we can convert pressures to saturation temperatures, but there's always gonna be a temperature probe could be 1.5 degrees plus or minus. So what we're seeing there is zero superheat, it's just the measurement uncertainty, that's why it's actually a little bit lower than that. Change in enthalpy now went up to 7.29, so we got a pretty big change in enthalpy. So now what do we think's wrong with the system? Now, just to put this in context, this is the 13 SEER, 1.5 ton Goodman. It's got an oversized evaporator, so it's got a 2-ton evaporator. And it also has a 2-ton condenser coil. Goodman uses a 2-ton condenser coil, but puts a 1.5 ton compressor in, so they don't have to have multiple chassis sizes, right? So now we're looking at all this data, and,
Dirty filter and dirty condenser coil.
okay, that's, I would say that's a pretty good guess. So, now how would you frame this to AI? What would you, so give me an idea of how you prompt this, and I'll just prompt it in.
The CFM or
Well, first of all, let's go back to the method. So what's the very first thing we wanna give it? We wanna tell it what? You wanna tell it you're a apprentice? Or you wanna tell it you're a senior technician? Or you wanna tell it you're a service manager? Or maybe you're head of troubleshooting for Goodman? What context do you wanna be in? Right, cause you wanna restrict it down. You don't want basic answers. If you ask it a really basic question, it's gonna give you a very basic answer. So if you think about the whole thing. So the first thing you wanna do is tell it we're a senior technician, right? Alright, so we already gave it, now we're giving it measurement data, we're giving it makes, we're giving it models, we're giving it serial numbers, right? So we gave it a data set. The next thing we wanna do is restrict it down now. So what do you think some of the, I mean, you think this is a bad TXV? I mean, are you gonna start throwing parts at this right away? So we wanna restrict it down to based off the measurements, don't throw parts at it until it gets done, right? So let's run this through here real quick. And we'll hit cancel here, let's close this up, cancel. Alright, so we got the stuff there. So you're a senior technician, comma, working on a Goodman 1.5 residential split system. Period. It's inside of a warehouse that's about 65 degrees. And pause it for a minute for my brain to catch up. The system was running fine a week ago, and the charge seems spot on. say it seemed, we can go ahead and edit that. Oops. We'll just delete that whole thing. Was good. Alright, what else do I wanna put in there? Give a little more information. What do we check? What things could we tell if we check?
The load in the house.
Yep, so we know it's low load in the house, but what things could you check?
Airflow.
Visually, like, it doesn't know, alright, so we could say,
Airflow.
Coil was clean, filter was good.
so the evaporator coil's clean, and the filter's clean. What problem should I be looking for?
Or why do I not have, you know, subcooling or superheat?
Alright, we'll restrict that.
Well, you're below 32 degrees.
Why don't I have any superheat, and why is my subcooling low? Alright. So we'll give it a second here. It looks like it stopped streaming.
Sometimes that Epson thing can lock up, you might have to go back into it to mirror it again.
Stop.
The coil's clean, but is it free of ice now? Because you're already below 32. And it's starting to freeze.
Did you have to cycle in with the projector or just?
Yeah, you might wanna go back through the HDMI.
Cause it's not saying it's even available up here for me.
Tell me when you're ready.
To the LAN connection.
Let me,
Lost
close
it.
that app and try it again here.
AI, what's wrong with that?
Oh, come on. Recycle my Wi-Fi once.
Vinny, did you save me any pizza?
Now's the time to get it, Brian.
No, I'm just messing
I'll
with
get
him.
it for you.
He needs like 4 pounds to,
You can
it's
put
a
your,
long ride home.
put your flip-flops on and get some papaya
Yeah,
too.
yeah,
There's papaya up there for you.
you know I would.
Come on, projector.
Tell me when you're up.
I don't even see it on my, is available.
Uh-oh.
Try cycling the power to it, Tom.
Power cycle.
Okay, I'm just gonna turn the projector off and bring it back up.
I will close that app. Alright, so it goes back up, we'll try it again. Alright, so this goes back to when you're playing with AI a little bit, is what can it see and it can't see. It can't see the condition of the condenser coil, it can't see the filters, it can't see the condition of the blower.
Smell gas.
So it can't smell gas, right? It can't see oil leaks, so you need to tell it some of the things that you want to know, otherwise it's just a completion engine. It's gonna try and give you the best answer it can based off what information it has. This is what makes a service manager at a company so important. Because what does a service manager do? Like any good service manager you've ever worked with or experienced, what does a service manager typically do as soon as you get on a phone with him?
Michael asks questions.
All right.
Six points of information.
Right, it's you start asking questions, right? Have you checked this, have you checked that? What's your static pressure? What's your superheat? What's your subcooling? What's your temperature? What's your pressure?
Oh.
Alright, there we go.
Start calling you Carl Jr.
Mirror device.
15 minutes into that conversation, you figure out you're not at the place you thought you were.
Well, this is the same issue that we have. One of the biggest problems we have is technicians that tell the service manager what the service manager wants to hear, right? So what's your superheat? It's about 10 degrees. What's your subcooling? Then what's a good service manager ask next? What's your saturation temperature? What's your line temperature? Well, that doesn't equal 12 degrees of superheat, or what you have.
Oh,
Are you up, Jim?
I'll try it again here. It showed it was up, but then it didn't go up. Now it's saying it's not found again. Let me try one more time. Oops, it just came up as soon as I said that.
All
Close
right.
the app.
It's not as fast as your fingers.
Alright, so it's there. Mirror the device. Start mirroring. I'm here. Start broadcast.
Come
It's
on,
like
you.
me trying to find the hotspot on
When you cycle it to HDMI, it's gonna force it to go off of the computer, so it might be canceling when he's trying to remote into it.
I'm
It's
in.
sourcing itself, Mike.
It is?
Yeah.
Okay.
There we go.
there.
Alright. So let's go back here. Alright, so good question. The data you posted is internally consistent once you step back. Alright, let's see here. Alright, space temperature, 65, outdoor 65, 10.5 fixed. Piston, airflow, flow, static pressure. Alright, so it's well outside the envelope. Why you have 0 superheat? Let's use your numbers. So it's calculating the superheat. The evaporator's completely flooded, but why? Contributor stacked, not isolated. So extremely low sensible heat load. You got a 65-degree return and low delta T demand, coil can't boil off the refrigerant. Severely low airflow, 235 CFM per ton, well below the minimum.
oh, yeah.
So airflow, low heat transfer. Fixed orifice behavior, piston does not modulate. At low load, it continues feeding liquid. Suction pressure does not drop fast. Self-correct, evaporator floods. That's what you'd expect. It's not a TXV failure, this is physics. Let's slow down there. Stop. All right, so now we got some numbers. So what's happening? Well, low load, but low mass flow. So I agree with that so far. Less refrigerant moving. Now this is interesting here. Now, saying I had a cold condenser. In the ambience cooled condenser typically rejects heat easily. Subcooling requires a liquid backup. You don't have enough mass flow to create it. Now that's not exactly true. Just think about what happens here. We have a piston system, and you nailed it. You said, what did you say was wrong with this? You said 2 things.
Airflow
Low airflow,
and dirty filters.
dirty, I think you said dirty condenser.
Yeah, dirty condenser. Yeah.
Dirty condenser, low airflow and a dirty condenser. Which is exactly right, because what I did is I went out in my shop and I actually blocked the airflow off with a damper, so I blocked my supplier down to create high static pressure on there, and then I have a rheostat on my condenser fan. I slowed my condenser fan way down to create effectively a dirty condenser on there, right? Now, what it's saying here is going back is that, let me go back to where that was, low load, low airflow. Alright, went down a little far here. Alright, so again, let's look at the system, not the numbers. Outdoor air 65 degrees, condenser approaches 19 degrees or higher for this condition, subcooling is low. Now, what's happening here, let's think about, this is all a game of what? It's finding the refrigerant. If I have high head pressure and I have a fixed orifice system, what did I just do? Where did I push all my refrigerant to?
Look at the evac.
I pushed it from the condenser into the evaporator, because I'm increasing the condensing pressure.
Oh,
So I'm
okay.
gonna force more refrigerant through the metering device, I'm gonna flood my evaporator coil. So if my superheat goes to 0, my evaporator coil is full. What's my subcooling gonna do when my superheat goes down? My subcooling is gonna go, think about what you're saying before you say it.
Your subcooling is gonna go down too, because it's not, you don't have a
I
full
was-
enough condenser to get to the subcooling circuit.
Well, I just migrated all the refrigerant out of my condenser into my evaporator. So I flooded my evaporator, I starved my condenser. So when I starve my condenser, I have low subcooling and I have low superheat. So it's a refrigerant migration problem, and it was caused because we had high head pressure pushed. If you think about I always think about a balance beam when I'm looking at a fixed orifice system. If I push down on the condenser, I'm gonna raise the refrigerant level in the evaporator. When I raise my refrigerant level in the evaporator, my superheat goes down, right? Cause this has less time to boil off, right? If I can also do it the other way and flood my condenser and starve my evaporator. So if I don't have enough differential pressure, like if it's warmer in the house than it is outside, I'm gonna have a very high superheat target. That's where it gets to like 30 degrees, superheat target, because I don't have that differential pressure required. Now, what'll also happen is we always charge by superheat, but there's also actually a target subcooling. So as we move refrigerant around, the subcooling will go up and down and the superheat goes up and down. All right,
Well, the unfortunate of this little example, we gave it false information.
what false information do we give it?
You said it, like the filters and all that stuff. was
Filters were
figured out.
clean.
You,
I had dialed down the dampers, supplier dampers. So the coils were clean, so I could have a bad capacitor, right, on a condenser fan motor, making the condenser fan motor run slow. And I could have the homeowner closed off all the dampers because their kid was going to college and they didn't need that cooling in all those rooms.
I guess so used to walking out.
We didn't
seeing
tell
it.
us, we didn't tell it all the coils were clean.
Well,
Yeah,
and this,
I mean, it's just a,
well, but you're right, what you're saying is right, I'm just being devil's advocate here, I'm just
no,
saying.
it's,
If you'd walked out and said the condenser fan motor's operating at full speed, the condenser fan motor height looks good, the more information you can give it, the better it's gonna complete the problem. It's trying to predict what the problem is, why it ran last week, what likely changed, right? Maybe you had a higher load, maybe more people on there, so let's see what it's not. What it's not is an undercharge, or an overcharge, or bad piston, or dirty coil, or not a refrigerant side restriction, not a compressor issue. So it's nailing these things down pretty well off this information. Root cause summary, severely restricted airflow. So, that's right, I closed
You
the
did
dampers
that.
down, right? Secondary contributors, low sensible load, operating outside design conditions. So the system isn't broken, it's being asked to run in conditions it wasn't designed for, alright? So what it actually needs to correct the airflow. So find restrictions in the ductwork. Do not adjust the charge, right? And then let's see, it says, if they got anything else here, it's good on here. Superheat because the evaporator can't blow refrigerant, blah, 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 this textbook example numbers are telling the truth.
That condenser fan?
Did it have that up there?
No, I just.
no, so I was watching for it,
Yeah.
and it doesn't, it's,
Alright,
This
think it
is,
says
and this
it
is
about
coming
here.
up with this online, totally separate from the recommendations in the measure book, right?
yeah, so now, let's go back to this for just a minute. So, that's a great question. So what would happen if we were to put that same result in the measure quick? Well, let me just get my glasses on so I can make sure I see the right one here. Cause I am pretty sure this thing takes photos and it goes backwards, so I think it's, no, it's not that one. I'm trying to look at the picture here. Oh, that's a combustion. Maybe I didn't pick that one. Low load and evaporator, oh, here it is. So, low load and evaporator, dirty condenser, non-condensables. So it's, in low load, if we go a little bit further into that, which I can't click on this picture because it's a photo, but it would tell you to check your airflow on the system. And then obviously dirty condenser, non-condensables. So we've run a lot of diagnostics through AI. I will not use it for diagnostics and measure quick. We've completely said, you know what? Doesn't work. It gets you there, it provides a really nice narrative, provides a lot of great information, but it's wrong more than it's right. And it's wrong more than it's right primarily because we don't give it enough information. If you do a really good job of walking through and explaining to it, it'll give you a fairly decent answer. Now, let's take a look at another one here. It's just interesting. One more before we wrap this up. And I'm gonna do one here, I believe that's pressures. I must be going the other direction. All right. All right, so this photo here, you can just take a peek at these numbers and this is a gas furnace, obviously.
So 90
It's an 80% efficient, 60,000 BTU input
okay.
is what it's rated at. And there's a couple things there.
CO.
CO's air free is, what's that number tell us right there? At
It's not
400,
safe- It's not safe to leave it there.
not safe to leave it there, right? We're over 400 parts per million CO air free, right? Why do we use air free? Cause there's two COs on here. This is the regular CO rating.
But you're looking
Because
at,
of dilution there.
Yeah, because the CO is diluted by the oxygen in there. So to get an apples to apples measurement, we use a CO air free measurement, which means that we take out the impact, the dilution of oxygen. So we know for sure that we have excessive amounts of CO. What else can you tell me, just at a glance on there?
it looks like the O2 is low.
O2 is low, which would tell us what else? If the O2 is low, what's probably high?
Well, it's CO for sure.
CO, but what else?
The gas.
Yeah, the gas pressure, very
Yeah,
good.
gas pressures, yeah.
So what do you think that's probably rated at? A nominal 3.5 and we're at 3.88 inches of water column.
3.9.
It's a 60,000 BTU rated appliance and it's 63,000 input. So it's definitely overfired, right? So now, just think about, in context though, if you don't tell AI that, hey, this is an 80 plus furnace, right? It doesn't know whether it's 80 plus. If you said, hey, what's my furnace doing? Well, it might tell you it's operating just fine, right? You gotta give it context. You gotta tell it, first of all, it's an 80% efficient furnace. Second of all, it's rated at 60,000 BTUs of input, right? The nominal manifold pressure is 3.5 inches of water column. So it's got some context to go with, otherwise it's gonna give you some bad readings to start with.
Do you have
Yeah.
a data plate for this one?
Yeah, I'll pop it in here in just a minute. So measure quick right away, picking up your top diagnostic, CO air freeze greater than 400. It's telling you to shut the appliance down and correct the circuit, just like Terry said, right? Gas input's high, it knows right away your gas input's high. Low stack temperature, now it's also got low stack temperature, I don't know if anybody caught that on there. That stack temperature is 250 degrees on an 80 plus appliance.
Coming close to condensing.
What's that?
You're coming close to condensing.
What temperature we condense?
150.
About 140 is what we want to, we want to be about, I believe it's 175 degrees hotter than the
Ambient.
temperature. So we're,
Then the fire temperature, because if you're bringing outdoor air in.
all right, so also, we picked up, we have high manifold pressure, we have high total external static pressure, and we have low draft on there. So basically what we got is an appliance here that was overfiring. Now, in our shop, to simulate draft, what I have is an induced draft fan, like a power venter. I had the power venter shut off. So now I'm overfiring, I got low airflow. This is all, MeasureQuick picked all this stuff up, okay? So now let's run this back through AI and see what AI does. So we go back here, and I'm gonna select this photo, and I'm not gonna give it our diagnostics. I'm gonna go ahead and give it the data plate off the furnace on there. So that's, let me make sure I got the right one there. Yeah, I did.
This
All right.
is the same data set for what we just looked at in measure.
Just what we looked at in MeasureQuick, yeah. So we'll verify it real quick. So 3.8 inches of water column, high static, 420
Why
CO.
is that showing draft is high?
The,
the other one say it was low?
it should be actually showing it as a low number.
So looking at that, Jim, while we're on that picture, you got check marks for the 4.302 and for the
Yeah, because it's
230 CO.
it's the O2 is, it's on the lower end, but it's not too low for that appliance.
Okay.
And the CO is itself is below 400 parts per million, but the CO air free is too high.
Gotcha.
So we watch CO to protect the analyzer, we watch CO air free to protect the occupants. All right? So let's go back here, and let me just double check and make sure I didn't, that's draft, I grabbed the right photo, all right.
Yeah.
So, go back to this, all right, cancel. All right, you're a senior service technician for Goodman. Could you go ahead and run an analysis on the data off this furnace, comparing it to the data plate? And let me know what we need to do to correct the operation, if anything. Lake Erie just got warmer. So, off the equipment data tag, it pulled in the model, 80% two-stage, high 60,000, lows 42,000, rated input, rated output, the temperature rise, the max design outlet temperature, the limit set point, all that's on the data plate for the furnace. So now it's got a lot of context to work with. Measure quick operating data, it's telling us the delta T is great, airflow is 1335 CFM. Now, here's another thing to stop and think about just for a minute. Modern gas appliances require more airflow typically than air conditioning does. This is only a 60,000 BTU furnace. Why is that airflow so high? I mean, that's 3 tons of air across the 60,000 BTU furnace. What are the manufacturers doing on these furnaces to get the efficiency up?
I'm trying to get the,
Lowering the delta T, a lower delta T. This thing's got a delta T.
It's at the high, it's within spec, but it's at the
And-
high range.
At 15 degrees, just
Oh,
do the
yeah.
math in your head real quick. 60,000 divided by 15,
It's 4.
4,000 CFM at 15 degrees. This furnace could have a 5-ton drive on it and not have the, I don't know how Goodman came up with a 15 to 45 degree rise. Combustion, manifold pressure is high, stack temperature is low, undiluted CO air free. What's right? Let's see here. All right, so the airflow is appropriate, explains why the delta T is in spite of the high static. The O2 is healthy, drafts established, no CO, no ambient CO, no rollout or instability. Now, how does it know that? It doesn't, it has no idea. It just threw that in there. This is the kind of things where it
Makes up
hallucinates,
shit.
it makes up shit. Yep. What's wrong and why? The furnace is overfired, right? Measured input 63, that's 5% overfire. Anybody know what the maximum overfire is for an appliance? Allowable? Here's something important, cause this furnace has a temperature rise rate, or a allowable manifold pressure of 3.2 to 3.8 inches.
Okay.
So that's a pretty wide range. But the input has to be within 2%. So you could have this furnace set up in the allowable range of manifold pressure between 3.2 and 3.8 inches, but still be overfired.
Wow.
Because the manifold, because the heat content of the gas can be higher, in this case in Ohio, we're at like 1070 BTUs per cubic foot. The furnace has orifices that were rated for 1,000 BTUs per cubic foot. So if you set your manifold pressure to 3.8 inches of water column, you could be way overfired on that appliance, over 2% of its rating, simply because we have the higher heat content of gas. So just because you have an allowable range doesn't mean if you're in range that you're not overfired, right? So output's higher than rated, static pressure is excessive. It's a system problem. So we're gonna have blower motor stress, reduced heat exchanger life, elevated noise. The ECM's bustling through bad duct system, which it is. We had a plug filter on this. CO is acceptable and too high for comfort. Oh, there's something dangerous. This goes back to, yeah, I'm never comfortable being dead, you know? But.
Well, you're not complaining.
No, but think about what this says right here, right? So it's saying, above 300 ppm tuning's required. At 400 air free, the furnace is not dangerous today. Well, that's not right, right? It's telling you something's off, fuel air balance. But this is the primary reason we don't want to rely on AI to make safety decisions, right? Phil will tell you his son's an attorney, and Phil, go to tell the story. It published a case from what year?
They quoted what the solution should be from a case heard by the Supreme Court in 2026.
It's even 2026.
Cool,
How
can
could
tell
the
the
Supreme
future.
Court have a
Tell the
case?
future,
What
yeah.
was the hot stock in 2026?
In the future, CO air free readings of 420 are gonna be fine, apparently. So, right, not dangerous today. Now, Terry knew right away that, what did you say? Don't leave that sucker running,
Yeah.
right? It's telling you something's off, the overfire's the root cause. So it's not all bad, but there's enough bad stuff here. If you sent Vincent out and you told Vincent to rely on AI, you tell his customer, yeah, it's a little high, it needs a little tuning, but it's safe to leave that way, and it's definitely not, right? Now, adjust the manifold pressure, clock the meter, verify the input, confirm, right? CO air pressure drops significantly, staff cut will normalize, output will be in there. It's not all bad, but it does give you bad advice. So it's about 90%, and this is why we don't rely on it in MeasureQuick to troubleshoot these problems. We'll let it do some things, but not everything, right? And then re-verify, and then final tech furnace. Is the furnace unsafe now?
Yes.
No, apparently not. Is it set up correctly? No. Primary results over fire. So, yeah, now, so let's give it a correction. I thought 400 ppm CO air free was over the ANSI standard. Why the hell are you telling me that's okay? We'll just fix ant.
I don't even talk to my family.
No, but I don't.
It's hard to get anyone else's.
You're right. Now, I want you to notice right away, what did we take early on?
It's gotta
It is
make you
a-
happy.
Trying to make you happy,
I
right?
was telling you, it's
You're-
sorry.
I misspoke. Let's clean that up and tie it to the actually standard, not into folklore, right? Now, we didn't tell it not to use folklore, so that's what it did. It says that airfree limit is 400 ppm. That is a hard limit, not a target. Exceeding its non-compliance. So 420 fails, right? But if you didn't tell it that it was wrong, it wouldn't agree with you that it was wrong. Right? And this is again why this stuff is interesting, but not something you want to rely on
So
because,
the information's there as long as you give it,
yeah.
if you
But-
ask the right
If
question.
you
But
ask
when
the
you
right
don't
question,
know what to ask,
but
it
if you
isn't
don't know
gonna
what
be
to
there
ask,
for
that's
you.
right. If you don't know what to ask,
What
if-
movie was that from? You gotta ask the right question. What the hell was that?
Sorry, Dave, I can't
So-
let you in.
all right, why my earlier statement was wrong and why you felt it. I used industry comfort language, not code language. Technicians often say, so you know what it did? It went out to Reddit. It literally went out online to a company like Reddit and said, that's okay, right? It's all right. So CO 400's a cliff, it already fell off, you're right to push back. So again, it's that whole thing making you feel good. So now all of a sudden I feel all better about AI and I think I'm gonna use it to do it, and it will make mistakes over and over. And if you get these threads longer, like if you have a long diagnostic problem, it'll get worse and worse and worse, because then it starts,
Stumbling on itself.
using its
Yeah.
own bad information back in.
One of the things that I've been doing with the Grok as I develop a understanding of how it works is I tell it which source to use when it comes to this kind of stuff, like ANSI, right?
Yeah, like,
Mm.
and but if you don't know what to expect, now what it would do good on is if we told it all the things that we checked and you asked it to summarize what we did for the day, right? Here's a list of things that I did. I checked this, I checked this, I checked this, I checked this. I came up with the results. Can you put it into a nice paragraph to explain to the homeowner, right? That's what it'll do good. Extract data off a label plate.
Unless it
that's
tells
what
me
it'll do good.
420 is okay and you're the homeowner.
Yeah. But yeah, this is where I will guarantee you this. With AI, we will make some of the biggest discoveries in the next 10 years of mankind. And we will also make some of the biggest mistakes. So I think it's really important to realize like where you guys are at as a company compared to most companies. Like there's knowledge here from all these old guys like Phil and Tom and me and Terry. There's like a lot of knowledge in the room, Brian. I'm sure you got a lot of that too. Years and years of experience that AI just doesn't have. And that's where you gotta tap into.
But it's gonna
Into
get,
the right people.
it'll be a lot better as the years, like you showed.
Oh, yeah,
earlier.
it'll definitely get better, but what I want you to see now, especially, guys Vincent's age is, it may help you figure out what's going on, but don't rely on it. Don't, pick up the phone and call somebody. Pick up the phone and call if you have questions, because it's gonna be a lot better solution than AI will. And like I said, I use it all the time, but I realize it's wrong, and it's wrong enough that I would never use it in our software to do a diagnostic. And I think it's important to think about that as you guys go through your work. It's a great tool, but it's
Dangerous.
a dangerous tool. Yeah, it's sort of like trying to fix everything with a hammer, right? So,
It's like dial a phone. It's like asking a question on Reddit.
yeah,
Your nail hammer's good.
Got a real good hammer.
yep. So anyway, well, that was my presentation, so hopefully you got a little out of it. It was interesting.
Good.
Yeah.
It was
And
something
timely.
different. Yeah, all right.
Thanks, Jim.
Yep.
Thanks, Jim.
Yeah.